Good morning, everyone. Welcome to Delhi on this pleasant morning. And since Dr. Jaisam Chopra has set the ball rolling, and let's go to the diagnostic part. As you all know, that non-invasive evaluation is a very important aspect of peripheral screening as well as diagnosis. The basic of diagnosis we come to know with ultrasound or with the Doppler itself. Before we go ahead with the techniques of doing Doppler imaging, I think we should know a little bit more about the machine. I don't know how many people in the sitting here are doing the diagnostic part, but little basic would be useful to everyone. So the topic given to me today is know your machine, knobs, controls, and transducer. This is the hospital from which I come from. This is Asian Institute of Medical Sciences. It's situated in Faridabad, NCR. It's a 350-bedded hospital, and we are doing all kind of cardiac and peripheral intervention procedures there. So what is knobology? Knobology is what probe to use, what button to press in order to obtain good images. Each ultrasound Doppler machine or the simple echo machine we are using for doing peripheral work, and they have a different kind of knobs. And each knob is assigned a specific function. This is a power on-off switch. This control turns the power supply of the ultrasound machine on or off. Then there are various connectors. Different machines have various probes, and we can pick and choose which probe we want to use. So it allows one to connect the desired ultrasound probe to the machine as illustrated. The various machine presets, there are automatic presets given by the company which we can pick up the desired work we want to do, whether we want to do a carotid Doppler imaging or an arterial Doppler or a venous Doppler. All kind of presets are already loaded on the machine on which peripheral work is to be done. Presets are programmed to optimize the images based on certain gain, power setting, focal zones, frame rate, and other settings. We can choose the correct preset before scanning. The preset selection, this kind of option is always there. We have to choose which kind of preset we want to take up, whether it is a vascular work or a small part ultrasound, etc. Then there are buttons for image optimization control. We can change the frequency of the probe. These kind of buttons can help us in changing the resolution of the machine, the penetration, or generally it can optimize between the resolution and penetration depending upon the work we want to do. If we opt for best resolution, then we need a higher frequency. If we use for best penetration, then lower frequency probes are to be used. So the buttons, they are there on the machine. You can use all kind of Doppler system for doing the peripheral work. There are buttons for depth control, which can change the field of view for the structure being imaged. You can go the depth up or depth down, depending upon what is the area of interest. Depth controls how much distance into the body the image displays into the far field. It is important to start deep to not miss the findings in the far field. Once the area of interest has been identified, you know that this is the area of interest, then you can adjust it. Once the far field has been surveyed, the depth can be decreased in order to focus on the area of importance. If the depth is decreased, then superficial structures will be magnified, which will improve the resolution. You can see this is a peripheral arterial Doppler being done. This is the external iliac artery, the superficial femoral artery, the profunda. And once the depth is increased, there is wasted space. As you know that the area of interest is right here, but we've increased the depth. There is a wasted space, and it affects the quality and frame rate of the image displayed. Adjust the depth to show area of interest in the top 2/3 or 3/4 of the screen. Then there are various buttons for gain. Gain can adjust the acoustic power of transmitted signals. It also adjusts the amplification of returning acoustic signals. There are various machines which can give us option for near gain and far gain to adjust the amplification of returning signals at a specific image depth. Then gain adjusts how the machine listens for return of echoes. If we increase the gain, the strength of returning echoes is amplified, thus a brighter image. And once you decrease the gain, that is in the upper image, once you increase the gain, the strength of returning echoes is amplified and thus brighter image. And on decreasing gain, it will darken the image. It can be adjusted for entire gain, that is overall gain, or there are certain buttons which are called time gain compensation or TGC. You can adjust the vertical gain or the horizontal gain depending upon the machine which you are using. TGC may be set as a column of sliding knobs or may be adjusted for near or far gain. Too much gain will increase the noise and wash out the image. Then there are buttons for freezing the image. It can freeze or unfreeze the image depending upon the area we want to see. The probes are generally described by the size and shape of their face. We use linear probes as well as phased array probes for imaging the peripheral arteries. Linear probes are generally higher frequency probes, that is between 5 to 13 hertz. And phase array probe, it generates an electronically steered beam in a closed system. These are the types of ultrasound probes we use, that is linear array probe, and a curved transducer is also sometimes used. In the linear array of ultrasound crystal, the transducer transmits parallel beams in a sequence, creating a feed that is as wide as a probe length, that is called the footprint. It gives us a large footprint and a narrow sector. This is the linear probe which we use. It is a higher frequency probe. Generally, we use is 7.5 megahertz. It is better for superficial structures and vessels. It generates rectangular images. It has good resolution and lesser penetration. The uses of linear probe are, it is ideal for superficial structures. The vascular excess can also be obtained, like central or peripheral lines can be put in using the linear probe. We can evaluate the deep venous thrombosis. Arterial Dopplers are done with this probe. Skin, soft tissue structures, tendons, bones, muscles can also be identified with this probe. The phased array transducer is the other option. That is, it has electronic steering. It can generate a beam sweeping at an angle. The footprint is smaller, but has a wide, far field of view. Example, this probe can also be used for echocardiography. It is also used for renal Dopplers. This probe is also small, and it's enough to fit in between the ribs, and still has a wide, far field of view to image the heart. These are the various options of probes available. The various frequencies are available. Then there is an ultrasound mode selector on the machine. We can do M mode, we can do Dopplers, we can do color Dopplers, and the 2D imaging is also there. First and foremost, the aim is to obtain a good B mode imaging before we start doing the Dopplers. It is also known as a basic grayscale imaging or a two-dimensional imaging. It is a standard black and white image. Then you can do a longitudinal scan of the arteries with the 2D mode. M mode can be cut across if we want to find something specific. Then comes the Doppler, that is, we can use the pulse wave Doppler, or sometimes continuous wave Doppler is also used. Pulse wave Doppler is that we put a cursor at a particular point and it gives us the velocity at that particular point. Important is that angle correction has to be used. The Doppler is always to be done at 60 degrees. That gives us the correct information. We will get very wrong information if the Doppler angle is less or more. So this is a pulse Doppler across the carotid artery. You can see that there is a systolic wave, the diastolic wave. We can calculate the velocity profile. But we have to be careful that the angle of the Doppler beam is assumed to be 60 degrees to the artery. That will give us the correct information. Other controls are image optimization controls, and which can automatically attempt to adjust the gain appropriately throughout the image. There is a zoom view which allows magnification. There is a focus which optimizes the lateral resolution at a given depth. Then there is a button of tissue harmonics. What is harmonics? We should know that when echo is reflected off an object, they will return at a fundamental frequency. But in harmonics, it becomes multiples of fundamental frequencies, that it could be two-time amplification or 4 times. Higher frequency waves experience less attenuation, less scatter, and generate clearer images. Color Doppler, it utilizes the pulse echo Doppler flow principles to generate a color image. This image is superimposed upon the 2D image. The red and blue display provides information regarding the direction and velocity of flow. It is used to visualize the blood flow and differentiate from the surrounding tissue. It provides a map for placing a Doppler sample volume, and the basic questions answered are, is there a flow present? what is the direction in which it is traveling, and how fast it is traveling. I'll just take about less than a minute. Direction of flow is regardless of the color. The top of the bar represents the flow coming towards the scan head, and bottom of the bar represents flow away from the scan head. Linear array scan head displays a square-shaped color box which steers from right to left to provide a Doppler angle. So this is when you start doing a Doppler, you know that how to put the color Doppler and what information you can gather. And normally, to get a good color Doppler, you have to see that the color fills the entire vessel or chamber of the wall. Just coming to the last two. So you can take a cut section, you can scan from the longitudinal view. The number one rule is that always begin with a good 2D image before turning on the color. That's the basic principle. And once you have a good 2D image, then you can put color and you'll get a lot of information. Thank you very much.